Where did you go? Oh, can't see that light. Tell me your name again. Yeah, you.
John.
John, and he's got his daughter and son,
Yes, correct. Yes, sir.
and we've got a new member there in the back. Tell us your name.
Sharon McKegg, or you can call me Trouble.
We're gonna have fun with you, aren't we? Who else we
We got
got?
a new member right here.
All right.
What's your name? I don't know who you are. What's your name?
Tell us
You
your
know my
name,
name.
lady.
This is Remington.
Remington, all right. What grade are you in, Remington? Fourth grade. You should move over here where I can see you. How are you behind that stand? Down this direction. There's Byron way over there in the far end. Somebody volunteered to do a head count for us here in a little bit.
You can recognize people with
Anna?
that don't have masks on. You can usually recognize them with their masks.
Okay, well, I hope most of you found a parking spot. Okay, Don, you get everything set up out there? I just left it. Why don't you stand up back there? This is our board member, Don Bradford. A little bit later on, we're gonna talk about volunteers for some things going on this spring, so you can contact me or Don, get your name on the list to help us out. So, I'm gonna take this off so I don't look so funny on Zoom. Can you hear me now?
Yep.
Doesn't sound like it's on, but I guess it is.
It is on. You're good.
All right, well, Mr. And you can start us up. I think we're going. I'd like to welcome you to the Astronomy Club of Tulsa 2022. This is our 85th anniversary of the club. It was established in the summer of 1937. I missed that meeting. But, I came along about 10 years later. But anyway, this club's been going strong ever since, one of their older clubs, especially in the Midwest. So we're going to be celebrating our anniversary this year, and one of the things we want to do is think of ways to do that. So if you want to be involved in that, got good ideas, things we can do, we're going to be having a board meeting pretty soon, and you know, as the weather gets warmer, we can do some things besides just come out here for meetings. But this is our 85th anniversary, and we already changed it. So our schedule tonight, we're going to talk about some upcoming events. We're going to talk about volunteer opportunities. A number of you already volunteered a couple of times. We had a big group at the gathering place, December 18th. We had 11 volunteers, and we froze ourselves, but I had several hundred people come by and look at the telescope, and we saw a newsletter. You know, they were also excited kids and moms and people of many different languages. We got a lot of contacts there, so that was a great opportunity for us. We're going to talk about the James Webb telescope that was just launched on Christmas Day. And I don't know what's happened to my Zoom here, but there we go. All right, the next one there, Mr. Dan. I want to thank Dan Zielinski back here. He's our host tonight. He runs the Jinx High School Planetarium. And you have meetings on Tuesday nights, is that right, Dan?
Yes, Joe. Sorry. Let me turn off
My mic, there we go. Tuesday nights, starting in February, you have it right, oh, you don't have it up there yet. Yeah, in February, we start back up with our public shows every Tuesday, and we go all the way till May.
Okay, I think there's a link to it in the newsletter.
There is.
If you go to our website, astrotulsa.com, and go up there at the top, it says About. You can find a link to the club brochure, a link to directions to our observatory, a link to the newsletters. And in there you'll find a link to the shows that they have here on Tuesdays. And a lot of the shows were done by, produced by, narrated by the students right here at Jinx High School. So you might want to check out some of those. There's some fun ones if you're really into adventure. There's one where you can ride a roller coaster. If your kids are into this video game called Minecraft, my grandson loves. We've got one where it's kind of like that old game Clue where you have multiple endings. They get to pick what tool they want to use, what planet they want to go to, and the outcome is different each show depending on what the audience picks. So, and I mentioned the one, My House is Full of Stars. No, that's not the name, is it?
No,
My House Has Stars.
My house is started, yeah.
It's a book, a children's book. It's mentioned in the newsletter that they made a planetarium show out of. And it's children from all over the world talking about the stars above their homes. So I really like that one because it's like, third, fourth, fifth graders reading it in children's voices. So that's really nice. So go come to some of their planetarium things. All right. Weather permitting, we're going to have some observing events coming up. We have a guest night coming up the 22nd. So if you're not we can come if you're a member, but if you're not a member, we are going to have a place on the website where you can RSVP, mainly so we can know how many guests we're going to have instead of get surprised. In wintertime, it's not too big a deal, but we've had over 100 in the summertime. That gets a little bit disconcerting if we don't know they're coming. But that's on the 22nd. Our observatory, there's a map to it under the direction section. It's about 25 miles southwest of here, southwest of the little town of Mounds. We're up on one of the higher hills around here. We have a nice view around. We have an observatory building up there and roughly an acre of open land where we can set up telescopes. Our members will have some telescopes up, and so you can come and look at a little darker skies than you have here at Tulsa. We have a members only night the following week near the new moon, and it doesn't mean if you want to bring your son or your daughter and you're a member, that's fine, but just going to bring a bunch of guests, because it's not going to be very special program that night. It'll be people doing their own program. Well, I'm going to have to take a break here because I forgot to tell my phone not to go to sleep, and it went to sleep. So we're now not on Zoom. Good old technology. Apologize for that. Never. That sounds like what was it Peter Pan meant to? Neverland. Okay, there's my ugly mug again. I think the camera's turned around, right?
Nope, just step in front of it, I think you're good.
You see me or not?
Nope, we see the room.
Right down there.
Yep.
Technology's not my thing. Okay, let's try again. Our next Jinx meeting will be February the 4th, right here at the planetarium again. Got several opportunities for the next guest night, but we haven't decided which one's going to work out best. So we have a board meeting coming up next week, and we're going to discuss where we're going to have that. But it'll be in mid-February. And then the members' night is on the 26th of February. So next slide.
John, I can do that flyer, we're gonna have telescope tomorrow morning.
Getting there, I'm getting there. Thank you. Okay, next slide. That's what we're talking about, club volunteers, opportunities for you to volunteer. It's a good opportunity for you to share your enthusiasm for astronomy, learn a little bit more from some of the others that are around, and to attract new members to our clubs. But we got observing nights out the observatory. We especially need extra people when we have guest night. At the members' night, we always need somebody to help open up, close up, and clean up, keep things, get things open and ready to go. And then we have some public opportunities, quite a few of them coming up back. Up there at the top is one of our guest nights at the observatory in the summertime, when you can see we had a big crowd. There's Jerry's big telescope there in the middle. Down here in the corner is the gathering place thing that we had December the 18th. And down in the other corner, one of our members, Nick Kuhn, went and set up a telescope for a Boy Scout group here in Tulsa. And we get those kinds of requests fairly frequently. So you can contact our friend Don there in the back about volunteering, or if you don't catch him, you can go to the contacts page and fill in your information and tell us you want to help volunteer, or just email me at astrotulsa.prez@gmail.com. But we need lots of volunteers. You've been in the club a year or more and they're interested in being more involved and helping us open and close and getting the key out there and accepting responsibilities that go with that, get a hold of me afterwards. All right, next one. This one just came up this week. The Parks Department is wanting us to come out to Hicks Park and have a star night, which is at 34th and Mingo, just west of Highway 69 and 31st Street. We're going to set up some telescopes there to the south of their building. They're going to have cocoa and some other things for people to come in and out from the neighborhood. That one we've got set up for 6:30 to 8 p.m. coming up February the 3rd. We'll have a little skinny crescent moon, and Jupiter will still be up a little bit on that day. And the next two just came out today. They were in the works, but haven't been fully developed yet. But Brad was talking about our Telescope 101 workshop. If you have a new telescope, if you have a telescope you don't know how to use, you can sign up to come to our workshop at the Tulsa Air and Space Museum. And somebody will help you for about a half an hour, figure out, what eyepieces work and how it all works, and give you some tips. We can't tell you everything about it, but we can kind of show you how to put it together and, go over your owner's manual and stuff, help you do that. But we need volunteers. If all the groups sign up, we'll have 10 people an hour for 10 people for 7 30-minute sessions, 70 people want to help with their telescopes. And some years, we've had a lot of success with it. Some years we have even more than that. But that means we need at least 15 volunteers to come out and help with everything. Welcome, you found a parking place, did you? That was an adventure, wasn't it? All right, and the other one just came about, the Creekwood Elementary School in Broken Arrow. I think they call it Tiger Lane, the rest of us call it 61st Street, between Lynn Lane and County Line. They want to have a STEM education night and want us to bring up some telescopes. But that is going to be the site of a solar system walkway, 2,000 feet long. We've shrunk the solar system down 1/10 billionth scale, but still a hike from the sun out to Pluto. I made him keep Pluto in, just still a planet. But it's about 2,000 feet away, so you get a nice long walk getting out to Pluto. And there'll be some big aluminum stanchions there with a information plate, and you can walk by, and I think they're supposed to have QR codes where you can scan and find out more information. But we raised enough money to get it in the manufacturing cycle, the first one, and hopefully it will get installed sometime in April or May before the school year ends. So those are two opportunities that just kind of got finalized the last couple of days. And the other one, I didn't get on here. I talked to the lady at Oxley Nature Center out there by the zoo, and they want us to come out on March the 12th. So lots of opportunities for us to share our love of astronomy, and you can come out and see the stars too. All right, next one. Already mentioned this, that we have our 71st anniversary. I don't know what happened to the Zoom. Am I still on it? I think we're just gonna have to give up on that. Go back. Anyway, ideas. I can't do everything, and I want your ideas. I'm not that creative anyway. Volunteers, we mentioned. Newsletter articles. Our friend Brad Young is always good to give us an article, but love to have some others. Anyway, some things that we can do. And while I'm thinking about it, I forgot to put it in here. We used to have a tradition in the club of show and tell. First part of the year, either first or second meeting, people would come and tell us about something new maybe they got for astronomy that year, a new book that they enjoyed, a new telescope, some new camera system, something that our members might be interested in. I'll send an email out about it. But if you want to bring up something that's small, tell us about it. Try it out a little bit before next February 4th. And tell us a little bit about it, or send us a picture. We'll get it in on the PowerPoint. And you can share a little bit about your new astronomical toys. So hopefully that'll be something interesting to do. So that's something I'm gonna see if we can't get started again. It was always fun to see what somebody else had, and maybe I want to buy one too. Anyway, okay, so again, you can contact me if you've got interest in doing that. Next one. Did anybody watch the James Webb Telescope come up Christmas morning? It was kind of early, 6:20 in the morning on Christmas morning. I had to dodge Santa's sleigh to get up. But anyway, the James Webb Telescope is long awaited. It's actually first proposed before the Hubble went up in late 80s, 89, I believe. It's an infrared telescope. I won't go into it too much because the videos we're going to watch don't explain that. It looks at a part of the spectrum with longer wavelengths than what our eyes can see, infrared. And that's kind of like heat in the latent heat in the universe. And infrared doesn't get scattered around as much as visible light, so it can penetrate a lot of the dust clouds in space. And infrared, since the universe is expanding rapidly, the visible wavelengths that we see in the early universe have been stretched out so far that they're below our visible range out in the infrared. So we have to see the early area, hopefully the early beginnings of the universe. But it's not going to be up in space like the Hubble Space Telescope. It's not going to be up in the orbit where we can go up and visit it and change out the equipment and repair it and do all of that kind of stuff. It's going to be 1,000,000 miles out beyond the moon at a place called Lagrange Point 2. And Lagrange points are, I can't quite understand it all, but there are places where the Earth's gravity, the sun's gravity, they all kind of are in balance. And the object can kind of stay in orbit around that position indefinitely. In fact, we see that naturally. We sent a spacecraft up last year called Lucy, and it's on the way to a whole bunch of asteroids that orbit in the same orbit with Jupiter out at the L4 or L5 position. Just kind of stuck there in front of or behind Jupiter. And we've had a spacecraft called SOHO at the L1 position, 1,000,000 miles in front of us, a couple of decades now, that observes the sun. And so it orbits that point. And we sent a couple of satellites out, I forgot the year, to the L4 and L5 positions so they can also observe the sun. They call stereo. They get one side and the other side of the sun so they can see most of the sun at the same time. So you're experienced in working with these Lagrange points, but once you send something out there, you can't fix it. It's out there. So you got to be sure everything is just right when you get there. All right, next one. Christmas morning, 6:20 in the morning, everything took off as planned. They launched from Prince Guiana. How do you pronounce that? Corfu. Anyway, thank you. They launched from there, and some of those things are screen captures that I did while I was watching it. And some of them are ones I got off the internet. But there's the rocket that they sent it up on. And there's the control room. At bottom, the little collage there, the bottom left corner is the actual image of the telescope taken from the booster rocket as it was leaving away and heading out into space. So it's going out there. It's already done some of its unfolding of its solar panels, but it's got to be a long ways from Earth to get away from Earth's interference and heat, and it's got to cool down to just 4 degrees above absolute zero. That is cold, and so to do that, we'll hear more about it in the videos. All right, next one. So why didn't we launch it from NASA? You know, they're in Florida like we do everything else. Well, it's a big, big spacecraft. It takes a lot of energy to get it way out to where it needs to go. And so by launching it from near the Earth's equator, the Earth spins faster in the equator than it does up here in Broken Arrow and Tulsa area. The Earth's circumference, as most of you know, is almost 25,000 miles around, 24,886, give or take a few. And the Earth spins in 23 hours, 56 minutes, and 4 seconds, not 24 hours. Do I know why that is? Dan knows. Tell us, Dan.
Well, we're not 24 hours because the extra 4 minutes accounts for the orbit of the Earth.
Right. Then that extra 4 minutes, every day we're also going around the sun. So it takes us 4 more minutes to get lined up with the sun. And it takes us 4 more minutes to watch the stars come up 4 minutes earlier a day. So the stars we see in the summertime, they're going down in the west. And they were coming up, 6 months ago in the east. So it gains time. Anyway, so at the equator, give or take a few miles per hour, we're ripping around at 1,040 miles an hour. Anybody know the speed of sound at sea level? 740, I believe it is. But Anyway, that's ripping on, isn't it? This Kennedy Space Center down there in southern Florida, I looked that up on the Googles, and its latitude is 28.5 degrees north. And so if you take the circumference of the Earth times the cosine of that angle, you come up with that 21,870 miles to go around Earth. It's just shorter track, you know. If you're running a race, you want to get on the inside track if you can. So there, the Earth is spinning at 914 miles an hour. If you go down to French Guiana, at just 5 degrees above the equator, about 300 miles or so north of the equator, it's spinning 1,035 miles an hour. Now that doesn't sound like much, does it? What's the difference there? 121 miles per hour? But you gotta remember your physics. The energy of a moving object is E equals mc squared. E, the energy, mass, the mass of the rocket's gonna stay the same. But the velocity of double it. So you're getting 28% more energy by moving down near the equator. So just so you can impress your friends, next time you watch the sunrise or sunset, you can tell them that we're spinning at 841 miles per hour here. In fact, if you've been to the observatory and looked through the telescope, if it doesn't have a drive system and you look in the eyepiece, the thing you're looking at is going to be out of there in a minute or two because we're spinning toward the east and it's not going with us. Anyway, that's why they launched it from French Guiana, to get the extra boost to get out to that point where they're going. So let's go to the next one. We're going to watch a couple of videos tonight that I found on the YouTube that I thought were pretty interesting. You got to remember, I'm a science geek, so hopefully you'll be interested. But first, I'm going to try to share a set of time-lapse images that our friend Brad over here took. Brad, you want to tell us about this before we look at it? Can you bring it up while we're doing that, and I'll let him tell us about it.
Okay, so if you look in the middle, sorry, I'm very unprepared for this. Yeah, there was 20.
That was me. That was me, but you got one now.
Yeah, just let him, well, just let him do that. I can't get you one. Oh, okay.
You were me, John.
So what this is the Space Telescope itself. And what's happening is you're seeing 60-second, 1 minute exposures, the first 4, and they're about a minute apart. And then I forgot that I had set up a reservation for later, so I got 4 more about 45 minutes later, and they are also 60-second exposures about a minute apart.
Tell them where your reservation was.
I'm getting to that. I did not take these photos with my, did not take them with my equipment. I took this with remote imaging, which I do all the time. This happens to be from New Mexico using a service called itelescope.com. And it happens to be on their cheapest telescope, T5, which is an old, it's still a fantastic telescope, but it's the oldest one on their system. And the reason I used it was because it's cheap and because I needed a fairly small field of view. I wish I could have gotten time on one of that needed a smaller field because it would have shown up better. But this is the entire field of view. I'm one of those people that doesn't like to crop anything unless they have to. So this is just a cheap telescope on a good mount with a good camera, but fairly wide field. And this cost me about $5. Of course, there's a lot of preparation time. You have to know where to look. There's some good sources for that if any of you are interested. just contact me. If you're interested in remote imaging, contact me and see anything. If it bothers you or enlightens you, then contact me. So that's the telescope itself. It had not really begun unfolding yet, but you'll notice that the first four are a little brighter than the next four, and that's because the first four were where it was just about opposite of us. It was highest in the sky, and what has unfolded was shining brighter, and later in the night it gets a little dimmer. If you looked at John's diagram, you will have noticed that L2 is, can you pull it back up real quick?
Yep. Yeah, I can.
I mean, can you pull L2 back up? That diagram.
Well, we'll have to do it back there.
Okay, never mind. Well, you probably remember that that was right behind, it was on line from the sun through the earth and moon and kind of behind everybody. There we go. And L2, where it sits about 1 million miles away, is, I hate to argue with John, but it's not as comfortable a place and steady a place as L5 and L4. But the good thing about L2 is, even though it's not quite as steady and it does require a little bit of energy to keep it there, it's the farthest out from all of the sources, because you'll notice it's farther out. This isn't really a scale, but it's farther out from the sun than L2 or L4 and L5 are, and it will never be affected by the sun where it is as much as it would have been if they put it at any of the other ones, except L3, which is very far away and would have taken a lot of fuel. So L2 is a good little mixture of short distance, but good stability.
Quick question, please. Has Webb reached L2? Is it close?
No, it's getting there.
Three-quarters away, or?
Well, it's going, this is in kilometers, but he's right, it's about 1 million miles. And if we go back to the GIF.
Oh, yours?
I'll have to put it on there. It must have just been on the website. Oh, there you go. This is my website. Good. Hold on.
Nope.
Okay, I thought I had put, well,
It's below this one.
okay, yeah, you know what I'm talking about. You know, you read it better than I did. There you go. It was already 572,000 miles away, but it's not, and that was fifth, yeah.
Dan, can you share the screen?
Yes, sir, sorry. They
No
had me swapping back and forth a lot. Hold on.
Oh, that's the screen.
I'm gonna just,
Anyway, it was about
just gonna
halfway
share.
there that night, and I think it gets to its final point within the next couple of weeks. It's not gonna take it very long. You know, it's basically just coasting there now.
I think I read it was a little bit more than 2 kilometers.
Okay, so it's already about 2/3 of it. Yeah, it's moving fast. I mean, it was, like John said, they launched it from the equator. They put an extra big rocket on it, even bigger than its payload required. They wanted to make sure that this $8 billion telescope made it. So there's a lot of things that they put into it to make it go really fast. Okay, can you go back up to the white on black, or white on white if it's yeah.
This one?
So, I'll go ahead.
This one is what you want?
Yeah.
Okay.
Oh, yeah, that's it. Some reason I thought John was driving it, but anyway. The booster is a lot harder to see because it's just basically a rocket body. It's not quite the cylindrical one you think about was the Saturn V or something, but it's a rocket body. It's not, doesn't have the shiny part that the telescope does, but it was out there. I was kind of surprised to get it. Same thing here, 4 and 4 sets here. And I circled it with a red dot so you can find it. And I also did crop this one and zoom it in quite a bit. But it was even further out. It kind of left the telescope behind, and it's going to go into solar orbit. I don't believe it's going to a Lagrange one. I think it's just going to look at the solar orbit, because they don't really want it to come back and get anything. If we could go to the next image.
Down?
Down, yeah. It just so happened, and this will give you an indication of the scale here. The red circle shows the booster. That was the negative image we just looked at where it was going between those two stars. And now you see why I didn't use the full scale. It's pretty small. If you're wondering how on earth I found this thing, obviously the coordinates, you need the coordinates of where to look for, but also when you get an image like this, you probably wouldn't notice that little dot going through those two stars, but the software I use, Astronomy, has a function where you can blink it, and as you blink them, blow it up like the one above, you can see these actually moving. And then there was a geosynchronous, or actually geosynchronous satellite going by, one that's out at about 22,000 miles. And I think there's one more shot of it. If you go down just a little bit more, you'll get the rest of the gift. Yeah, it was passing by. I caught it on 3 frames. And that gives you some idea of distance scale here. The bottom streak going across is every 60 seconds of a satellite that's 22,000 miles up. That's essentially our span, like John was talking about. The satellite is meant to stay over just about over one spot. So that's really our rotation in 60.
This is not moving, we're moving.
Right, it's not moving, we're moving, exactly. And so that shows you how that works. But also think about the fact that the streaks geosynchronous satellite is 22,000 miles up, and that booster rocket is about, I said, 652,000 miles up at this point. So that's why it doesn't streak. That was the first thing my wife asked me, how come that one doesn't streak like the other one? Well, it does, but the streaks are so small that you don't really notice them. It just shows up at the dot. And I think that was all the images I had of that one. If you want to go ahead.
Get on there,
Yeah.
programs. All right, well, that was very good. Hopefully we can get you to tell us more about that remote imaging. That sounds very interesting.
$99.99, John.
Well, okay. So the first one is an interview with Dr. John Mather. So we'll go watch that. And then the next one is, I think it's a British show called Insane Engineering. But as you can, well, I don't have the image there, but they had to shield this thing from the sun. In order to do that, they put some giant reflecting films, 4 layers that are about the size of a tennis court. And if you'll listen carefully, I think they said they had to dump off 200,000 watts of solar energy to keep it from getting to the telescope. So anyway, listen for some details during the videos. So Dan, I'm going to turn it over to you, and I'm going to have a seat.
You want this? You want